This next video goes along with slides 5 and 6. Let's go deeper. Hello, details of water. All right, so what I want you to do is give additional information and observations in the boxes below based on what I'm about to show you here. Hopefully, you came up with your brainstorm from the previous slide. Hopefully, you came up with names like Atlantic Ocean, Pacific Ocean, Indian Ocean for your saltwater examples. Hopefully, for fresh solid, you said things like the polar ice caps or Antarctica, things like that. And for freshwater, you could have had anything from lakes and streams and rivers to the Potomac River, the Mississippi River, Lake Anna, all kinds of examples like that. If you didn't, pause the video go back now and plug some of those things in that I just said. But what I'm going to show you now gets a little bit more detailed. So I want you to watch what I'm doing, and then after I do this, I want you to include your observations and additional information for each type of water that I show you. And it also says, what do you think about what you saw? So I've got a whole bunch of fancy math here that I've done to help me figure out what I'm about to do next with you. And what I'm focusing on, guys, is the far right column, the freshwater liquid only. So I'm only worried about this guy right now, this 9.4 milliliters. What I want to do here is show you how much of that would be fresh liquid groundwater and how much would be fresh liquid surface water. Now, which one of these do you think you interact with the most? Right? Surface water. You see this, your rivers, your streams, your creeks, your lakes. This is the stuff underground, flowing underground, where we get so much of our water from. If you're on a well, there you go. You absolutely depend on it. Okay? So let's take a look now. My fancy math tells me that of this 9.4 milliliters, 9 of it is groundwater. I can't even do that. I have to take out my 0.4 first because it's not going to register at the bottom. So I got to take out my 0.4 first. So I'm at 9.4 . A bit more than that, obviously. All right, this is not going to be perfect. So I just want to have 9 in here, a little bit more out. All right. Okay. On this planet, 9 milliliters, groundwater. 0.4 representing all of your lakes and your rivers and your streams and your wetlands and all your swamps. All that river stuff that you see. That's it. And now using this, I'm going a step further. I'm going to take this and divide it into our lakes, swamps, wetlands, rivers. This isn't really going to be perfect, guys. I tried this twice yesterday and couldn't quite get it where I wanted it to. Essentially, out of this 0.4 that's left, it comes out to what would be approximately, and I'm not going to get it right, it would be 6 drops, and I can't even fill my whole thing up here. Look at that. Like, I'm not even going to get this out right. But it would be 6 drops in here. They're not equal size drops. 6 drops would go to the lakes. About 2 drops would go to the swamps. And less than a drop would go to the rivers. So again, I can't even get this to space out correctly so that I'm not getting air in it. I'm not getting equal size drops to come out, but I'll say that again. Of the 0.4 milliliters that is represented here, most of it would be in our lakes, like our deep lakes, like the Great Lakes. Some more, but smaller, a third of that, would be in our swamps and wetlands, bogs, things like that. And then the stuff that you get to see, the Shenandoah, the Potomac, the Mississippi, all of our rivers and streams would be that tiny amount. Again, we're not to scale. I did some fancy math to try to figure it out, to get something as close as possible to represent for you. Here's the thing. Oceans, rivers. That's it. That's it. That is how our water is divided on our planet. Take a look at the next slide for the details that I just showed you. It's broken down a little bit more cleanly than this demonstration is showing you. Go ahead.